In this lesson, we're going to look at what is called the discriminant. So as you know, we can use the quadratic formula to find the roots of a quadratic. So remember, roots are also called x-intercepts. We are trying to find the value of x when y equals 0. You might see them as called zeros. You might see them as called solutions because we are solving. Solving means find the value of x when y is 0. So those are all meaning the same thing. So finding the roots basically means find where the quadratic passes through the x-axis or when y is 0 at that point. And so the reason we have this quadratic formula, remember that a quadratic is symmetrical. So let's say we had x-intercepts here and here. The middle, so they are 6 units apart, so the middle would be here. This is our axis of symmetry because it is symmetrical. So this middle cuts it in half, and then the root to the right is the same distance as the root to the left. So this part of the quadratic formula is the middle. And then this is describing what distance we go to the right and to the left. So sometimes you can use a shortcut for finding the vertex by saying, well, the value of the vertex, the x-coordinate, right, our vertex is here, would be found at negative b over 2a. That would be the x-coordinate, the vertex, and then we go plus b squared minus 4ac to the right, minus b squared minus 4ac to the left. So what if we don't want to know the roots? We just want to know how many there are. So we can use just the part that's inside the quadratic formula, the b squared minus 4ac, and this is called the discriminant. This tells us how many roots there are. So we could potentially have 2 roots. It could pass through twice. So whether it's concave up or concave down, it could have 1 root. It could sit right on the x-axis. Or it could have no roots. Doesn't have to pass through at all. So let's have a look at a couple of examples. So let's say we had the function x squared plus 3x minus 4. So all we're determining is b squared minus 4ac. So with that first one, it would be, well, b is 3, a is 1, and c is negative 4. So that works out to be 9 plus 16, which is 25. So it is a positive value. And if we graphed that first one, it looks like this. So if I go to Desmos and graph that, it looks like that. And I can see that it passes through twice. So it has 2 real, and we say distinct because they're different. Distinct means different. The other way I can check is to actually factor and find the roots. So 2 numbers that multiply to get 4 and add to get 3 would be 4 and 1. So I can see it does have 2 roots at negative 4 and 1. But I don't really want to do the factoring. I just want to know how many it has. So I'm just determining b squared minus 4ac. If I had the second one, x squared minus 6x plus 9, b is negative 6, a is 1, and c is 9. That equals 36 minus 36, which equals 0. And if I graphed that, I would find that it sits right on the x-axis at 3. And why is that? Well, if I factored it, I would have x minus 3 times x minus 3. It's a perfect square. So I only have 1 root at x equals 3 because they are the same. So when we say they are real and distinct, that means they are real and different. We could say they're real and the same. So you have 2 real roots, right? I have 2 factors, but they are the same. So in this one we have 2 real and equal roots. So they are the same. This one I have 2 real and distinct. They are different. Okay, let's do x squared plus 3x plus 7, so it would be 3 squared minus 4, a is 1, c is 7. That works out to be negative 19. So it is a negative value. It has no real roots. If I graph that on Desmos, that third one has a vertex over here and is concave up. That tells me that there are no real roots. Okay, let's do the next one. So b is negative 4, a is 2, c is 3. That works out to be negative 8. So again, it's negative. It would have no real roots. If I graphed that last one, it has a vertex over here and is concave up. So I can confirm by Desmos whether it is what it looks like. Just type it into Desmos. So what can we conclude? If the b squared minus 4ac, the discriminant, is positive, we would have two real and distinct roots, meaning we have two real and different roots. If it is equal to 0, we would have two real and equal roots, which means one root. So, or one root. And if it's negative, we have no real roots or imaginary roots. And so if it's positive, I would get two roots that pass through the x-axis. If it's 0, I would have two real but equal, so therefore one root sitting somewhere on the x-axis. And if I had no real roots, it would not pass through the x-axis. Just going back to the no real roots. If the discriminant is negative, right, let's say it's negative, I know I can't square root a negative, that's why there's no real roots. So if your discriminant number is negative, you also confirms that I can't square root a negative, that means that there's no real roots. So in this question, you're just looking for the number of roots using the discriminant. I don't know if I can turn this around. A little bit sideways. So let's just do the first one. So all we're doing is b squared minus 4ac. Don't forget to put brackets if it's negative. A is 1, c is 8. That's 16 minus 32, which is negative 16. So that tells me that there are no real roots. And then the answers are just at the bottom here. Okay, so you can try those. Okay, other types of questions you'll get are missing coefficients. So I have a quadratic here. K represents a missing number. So I want a quadratic that has two real and equal roots. So if it has two real and equal roots, the discriminant would equal 0. So in this question, a is 2, b is negative k, c is k. So these are the coefficients. So a is a coefficient on the x squared, b is the coefficient on the x, and c is the constant. So I'm going to plug these into the equation here. B is negative k, a is 2, and c is k. So negative k squared is k squared. 4 times 2 is 8, 8k. I'm going to factor to solve for k. So k equals 0 or k equals 8. So what does that mean? Well, if k equals 0, so let's go back to the original question. If k equals 0, then the equation would be 2x squared, and I would have no more terms because k is 0. Well, what does that look like? Well, that looks like a quadratic that is passing through the origin and has been vertically stretched. So it has one real root, so that confirms that the value of k equals 0 makes one real root. So remember, two real and equal means one root. If k equals 8, the equation would be 2x squared minus 8x plus 8. So I'm going to factor. And if I factor, I see I get 2 real roots, but they're both the same, so I have 1 root. So that confirms as well. So there's a couple of examples down at the bottom here where you can practice, and the answers are at the end.